Okay, next electrophilic substitution reaction is Wills-Verhack formylation. Is well-known reaction as we know. So we'll see now what is the mechanism and all. So Wills-Verhack formylation reaction in case of indole. So we know the Wills-Verhack formatting reagent and then dimethyl formamide and POCl3. Uh, so we have to do a reaction with this one. First one we have to generate the Wills-Verhack reagent. This one, okay, Wills-Verhack reagent. So formylation occurs at the third position. So indole 3 aldehyde we got. So Wills-Verhack reaction is efficient method for the formulation of electron-rich aromatic rings by use of acid chloride, POCl3 and DMF. Indoles can be readily formulated through 3-formyl indole via Wills-Verhack reaction. Even indoles carrying an electron withdrawing group at the second position, for example, ethyl 2-indole carboxylate, undergoes smooth Wills-Verhack 3 formulation reaction. So the mechanism of Wills-Verhack reaction, you know very well. So first one we have to synthesize Wills-Verhack reagent. This type of Wills-Verhack reagent possessing positive charge on nitrogen. That one we have generated from the DMF and then dimethyl formamide from here, from this reagent and this run. We will say the DMF 5 degrees centigrade. So we will get this type of electrophile. It acts as an electrophile, and indole ring acts as a nucleophile. So this is nucleophilic addition, and see over here how the nucleophilic addition occurs. Then once we have generated carbon single bond, we can do further elimination reaction or addition reaction. In this mechanism is explained over here how carbon carbon double bond is forming. Then we have to do the hydrolysis. Then how the hydrolysis gives this CHO. Okay, so mechanism. First one, you have to write down the synthesis of Wills-Verhack reagent mechanism. Okay, Wills-Verhack reagent mechanism. First one, you have to show this one, synthesis of this one or preparation of this one, this reagent, and then you have to react this reagent with nucleophilic indole in this way. Finally, to get this aldehyde group at the third position. Okay, so Wills-Verhack reaction for the indole. So Wills-Verhack, whenever if somebody will ask you Wills-Verhack reagent for any heterocycle, you should be able to explain all mechanism, all mechanistic step you have to include for subjective type of questions. Okay. Manage reaction. Okay, so next important reaction of indole is manage reaction with ammonium ion. Indole reacts with mixture of formaldehyde and dimethylamine at 0 degrees centigrade in neutral conditions to give n substituted dimethyl amino methyl indole. Under neutral conditions at higher temperature or in acidic medium acetic acid, N-substituted dimethyl amino methyl indole get transformed into thermodynamically more stable 3-dimethyl amino methyl indole. That is nothing but the gramine. Okay, so gramine synthesis we will see. Gramine can be directly prepared in high yield by reaction of indole with formaldehyde and dimethylamine in acetic acid. The managed reaction is useful because the product gramine can be used as intermediate to assess various 3-substituted indole. Okay, so we'll see now what is the gramine and how we can achieve it from indole. So here is the reaction, and pay attention how the managed reaction is useful to synthesis of gramine. Okay, this is gramine. Gramine is nothing but the product from the managed reaction of indole. Okay, so gramine, and this gramine we can synthesize for to synthesize different different reactions or different important drugs or alkaloids from this starting material. Okay, so starting indole managed reaction, we do take normally non-enolizable aldehyde, formaldehyde, and dimethylamine, water 0 degrees centigrade. So here also we are getting N-methylated product. Okay, so here is getting this substituent is getting attached to this nitrogen because NH is acidic. So here in this way we get the managed base. This managed base on treatment with water, heat 93% or acetic acid, room temperature 68 degrees Celsius. So shifting of this functional group and then dimethyl and CH2 to this third position to generate this gramine. Okay, so how to do from here, how to go from here to direct gramine. What are the reaction conditions? So HCOH and a dimethyl acetic acid room temperature. Same thing they have given. We have generated this iminium ion, iminium cation, and this iminium cation reacts with this indole to get this one. Okay, so mechanism they have given here of managed reaction. Formaldehyde, that this one we have generated. Okay, iminium cation. Iminium cation, how we do, we are at acts as a nucleo electrophile. Iminium cation, you know very well, in managed reaction we have learned it already. And this is iminium cation. How the reaction performs, what is the mechanism, then the elimination of proton, it retains its aromaticity. So in this way we can synthesize this gramine plant alkaloid. Okay, so now we'll see now what is the use of this gramine, synthetic application of gramine and especially quaternary salt are useful synthetic intermediate as they are easily prepared and the dimethyl amino group is easily displaced by nucleophiles. For example, reaction with cyanide and acetamidomalonate anions. Okay, so gramines we are going to use to synthesize for another molecule. The electron donating power is never better demonstrated than in case of managed base. For the removal of dimethyl amino group, normal managed bases requires alkylation to convert them to its quaternary salt before elimination by heating. However, in case of indole derived managed bases, no alkylation is needed. And nitrogen of indole itself can expel dimethyl amino group in presence of cyanide ion. The electric reaction is slow but gives high yield. We'll see now what they wanted to see here. So tryptophan. So here I wanted to show you the tryptophan has listed in your syllabus synthesis of tryptophan. Okay, so fourth point, D point in your 5301 section, synthesis of different things. In that one we have seen papaver and tryptophan. So tryptophan, indole containing moiety. So here we are going to synthesize this tryptophan after synthesis of tryptamine. So first we will see synthesis of tryptamine. So how the gramine we can convert to this important things, tryptamine. So gramine, okay, we do want to eliminate this N dimethyl group. Okay, and how to carry out this one in presence of sodium cyanide as strong base, cyanide minus at abstracts proton. So in this way we can eliminate N dimethyl amine. Okay, so beta-alkylating indolinin we got here. Again, cyanide ions attacks on the carbon-carbon double bond, and that one is shifting region. That means regain it. It helps out indole to regain its aromaticity. Once cyanide group is getting attached over here, on this acid or base hydrolysis, cyanide groups converted into COH, so you can get indole 3 acetic acid. This is also very important, indole 3 acetic acid, as a pesticide or okay, so you can find application of this one, indole 3 acetic. This one I think acts as a pesticide or insecticide, indole 3 acetic acid, or maybe something different used in, but in agricultural field we can use this indole 3 acetic acid. Again, this cyano containing indole moiety on reduction, LiLH4 reduction, so we can convert this cyanide to CH2 NH2. Okay, so that is nothing but the tryptamine. Okay, tryptamine, we have seen how to synthesize tryptamine. We have seen how to synthesize gramine to tryptamine. Now we will see the synthesis of tryptophan from gramine. So managed reaction of indole and whatever the product you are getting, gramine. So how, see what are, how many different uses of that gramine, how many different moieties or essential molecules we can synthesize from this gramine. Okay, again this gramine on treatment with diethyl acetamidomalonate. Okay, diethyl acetamidomalonate in presence of toluene and heat 90 degrees centigrade. We do this elimination of N-dimethyl and generation of new carbon-carbon single bond. And this molecule on treatment with acid, aqueous sodium hydroxide, then H2SO4 heat, we can get tryptophan. Okay, so this is the synthesis of tryptophan. If you want to see how is the mechanism occurs over here or over here, please go for literature survey. And if I am finding that one, definitely I will drop you in you to you in my next lecture.